Hello, everyone, and welcome to Neurocracy. Today, we're joined by Dr. Bryce Mander, an associate professor of psychiatry and human behavior at the UC Irvine School of Medicine. His lab uses multimodal neuroimaging and sleep EEG to map how sleep quality and specific brain rhythms relate to memory and Alzheimer's disease biology. Dr. Mander, thank you so much for joining me today.
Really honor and pleasure to be here, Sanjay. Thank you for inviting me.
Thank you for joining me. So, what first got you interested in studying sleep and memory?
The sleep and memory connection actually goes way back in my time. So I had always been interested in sleep. I grew up in a household of psychologists, so sleep
Oh,
is
wow.
kind of an interesting topic of conversation. I
Yeah.
did a high school senior project that involved sleep.
Oh,
But the sleep and memory connection really came. I was working as an undergraduate research assistant at University of Chicago,
oh,
and
wow.
during that time, I was working in a sleep research lab that was an endocrinology lab actually, and we were interested in how short sleep or sleep loss can impact glucose metabolism and insulin resistance.
Okay.
And we were using a piece of technology a little aware now there are now a bunch of them on the market now, but this was many years ago. There was this little thing where you wear a headband, you put a little sensor on your eyelid, and you can kind of it could tell when you're in sort of REM sleep because your eyelids are moving back and forth. And it was kind of like a wearable way of trying to get how much time you're in different sleep stages. And one of the people who developed it was this famous sleep researcher named Bob Stickold, and he was just a
Okay.
really nice, very brilliant man, and who was at Harvard. But he knew my principal investigator, my boss. He knew
Yeah.
her, and we were using that technology, and we were talking about it. And he came to visit so that we could kind of figure out the best way to use this technology to do research. And it was there that he was just starting to kind of get, some of his big kind of early sleep and memory work out into the literature. So he talked about that work and we had these conversations and it just really sparked an interest in me that I just, couldn't let go of. And that sort of led me towards my graduate school career where I studied sleep and brain function in young and older people.
Oh,
And
wow.
then I met some other memory scientists who are interested in sleep and memory there at Northwestern University. And then I went on to my postdoc at Berkeley working with Matt Walker there.
Oh,
And that's where
wow.
I really
Okay.
focused on sleep and
That's
memory there.
cool. Yeah.
Sorry, give me 1 second. Sorry,
Okay.
just give me
Yeah.
1 second. I'm sorry if we have to pause this.
Yeah,
My
yeah, that's
son
fine.
keeps banging on the door.
Okay, okay. Yeah. But no, actually, just I'll just talk a little bit.
Yeah.
I actually I was reading Why We Sleep by Dr. Matthew Walker
Oh, yeah. Mhm.
just a couple months ago, and it's funny that that book actually inspired me to do a research project. So I'm actually a speed cuber. So
Oh.
I'm a competitive speed cuber. So I actually hold the Missouri record. I average like 7 seconds on 3x3.
Wow.
And one of the sentences in his book caught my eye. It was like it's really early in the book, but it's about like how Olympic records are tied to a certain time of day. I believe in the book it was like 1 p.m. And during the time like I was really like going out to Rubik's Cube competitions and competing. And I personally noticed that I always do like disproportionately worse in the second round even though there's not too much of a time difference between the first round and the second round. And like I basically I remember I was interviewing another professor, Dr. Rebecca Spencer. At,
Oh, yes, Becky, she's wonderful.
oh,
Brilliant
that's good. That's
scientist.
good. You know her. Yeah. So I remember I was telling her about like my idea of maybe there's some sort of association between like the time of day and when Rubik's Cube records tend to be broken, inspired by the
Interesting.
when the connection between the Olympic records and when they're broken. So I remember there's a huge public database that I never found any use for personally until I had this idea to kind of like do some research with it because all the timestamps are stored for all the records. So I spent quite a lot of time like the next few months after speaking with Dr. Spencer and then I downloaded all these files and then I ran some Python scripts to like connect the time of day to when the records are
Mm.
broken. And I found that so a lot of like the competitors who are
Huh.
able to make these records like national, world, or even like regional, they tend to have the same number of solves in that first round, which tends to be around like 9 a.m. to like
Mm.
9:30 a.m. And the second round tends to fall under like 12:30 p.m. to 2 p.m. And I noticed that even though they do like the same number of solves in total, there's way more records that happen at that morning, like 9 a.m.
Fascinating.
Time. And I was kind of attributing it to like a circadian dip.
Yeah.
and later in the day. And that's what Dr. Spencer and I were talking about in the interview. So
Mm.
that was one explanation. And another explanation is
Mhm.
also like fatigue
Yeah.
because you spend a few hours like cubing at the competition itself. But no,
Yeah.
I
I
just
think
thought it was
both of those
interesting.
are probably not mutually exclusive and probably
Yeah.
interacting. It's interesting you touch on that,
Yeah.
because probably, and you probably talked with Becky about this too, Dr. Spencer, because she's a real expert in sleep and motor learning. And when she was really getting started out doing sleep research, it was a lot of it was focused on the explicit versus implicit motor learning stuff.
Yeah.
Um, but there's a couple of different components to motor learning that kind of interact to impact how we understand the role of sleep in it. Yeah, in probably the most studied form of sleep dependent memory is actually motor learning. It's
Oh,
actually
wow.
that there's this task called a motor skill task where you're given a series of numbers and you have to type them in a very specific sequence with your non-dominant hand. And the faster and most accurate you can do it, kind of the better you get. And when you
Yeah.
start out in your non-dominant hand, you're not doing so great. Now, granted, if you're an avid piano player
Yeah.
or you're ambidextrous or
Yeah.
you do things similar to that, then you get to your ceiling much quicker, and there's not much of a difference from
Right.
of a learning curve. But for most people like myself, there's a pretty obvious learning curve when that you start out pretty slow and then you get better and better and better and better. Someone like you who can do Rubik's Cube in 7 seconds might find this task easy, but um, but that learning curve itself is impacted by both how what's the time between your trials, and kind of how much rest you give yourself. So there's a fatigue effect on the learning of it itself,
Oh, yeah.
and that affects actually where you plateau. And even if you give yourself a 30-minute break to do nothing but just rest your hand, you get a bump in your performance. It's pretty significant.
Wow.
And for many years we hadn't known that in the field, and so we thought that sleep actually enhanced motor learning overnight.
Mm.
Um, but actually, it wasn't that it was enhanced. It was that the your peak baseline performance before sleep was masked by fatigue.
Oh,
And then when you rested, you restored that fatigue. So what sleep was
yeah.
really doing was it was consolidating and stabilizing your peak performance. So it was still helping memory. It was still consolidating memory. It was still
Right.
processing that memory. It was just keeping it from decaying because you practice something a while. If you don't do anything for a while, then you start to not remembered as
Yeah.
well or not be as
Yeah.
good at it anymore. So that's why continual practice is so important to maintain peak performance. Well,
Yeah.
sleep kind of helps solidify that for a period of time. And if you didn't have sleep, you'd start to decay again. And so that kind of drastically shifted how we thought about the literature. And so it's interesting because what you're talking about with this sort of Rubik's Cube thing is you're seeing that there's a time of day effect on your performance.
Mhm.
But there's also probably a fatiguing effect on peak performance as well. And they're probably interacting with each other. They might even be
Yeah.
magnifying the effect.
Yeah.
I guess the only other way to really separate the two is if you did an experiment where you
Yeah.
showed people didn't practice in the morning and they just did the afternoon, and would they be as
Yeah, that
fast
would
as
be the
you?
step. And but the benefit for me in not doing that is the fact that all the data is like listed out in terms of like me
Oh,
extracting
for
it.
sure.
Or yeah.
Yeah.
So, but that would be
I mean,
something
in
interesting to
itself, you
explore.
could probably write a paper on that. That's really
Yeah,
neat
so
work that you
actually I
did.
did write like a paper on it like myself. I'm not sure how like regarded it is, but I submitted it
Mm.
for consideration to present at the Society for Research on Biological Rhythms conference in May.
Oh,
So I'll
cool.
I'll hear soon if I get accepted to
Well,
that. And then I
congratulations.
also
Yeah, I
submitted
mean,
it.
I
Yeah.
that's great you wrote. So it sounds like you wrote an abstract
Yeah.
to
I wrote the
present at a
abstract for
conference,
them. Yeah.
which is really good. And that's for your stage of your, kind of your scientific career, that's really huge. But
Yeah.
I'm even saying that you might even be able to publish something
Well,
on that.
yeah, that's the next thing I was gonna say. I submitted like a
Yeah.
manuscript to the journal Circadian Rhythms. I'm
Oh,
not sure
cool.
if you know of that journal, but
Oh, yeah. Oh, yeah,
so I'll
for
hear
sure.
back from them hopefully, like in a few months or a few weeks, and based on that, I'll let you know. Actually, I'll keep you updated on how that goes.
Yeah, but that's great.
Yeah.
That's great work.
Yeah, no,
It's amazing.
it's fun for me because I've been like really interested in sleep for a long time and Rubik's cubes, and there's never been that like way for me to connect it. But now there's like that really exciting way to like, oh, like not only am I doing what I love, but maybe I'll be able to contribute something to
Yeah.
literature in a unique way. So yeah, this is something really fun.
It's amazing how many things, in terms of the sort of the memory space, how many things turn out to be sleep dependent.
Yeah.
To give you a sense of it, even learning how to visually stage sleep stages is a sleep dependent memory skill.
That's funny.
So you
Yeah.
do it enough, you practice enough, you sleep on it, boom. Yeah,
Yeah,
so
that's
it's
true.
it's interesting. It's like anything that requires a memory to transform itself to be more automated tends to have a sleep benefit. Anything with an explicit piece of information to remember, anything with context or spatial relations, stuff. There's a lot of stuff that's impacted by sleep. A lot
Yeah.
of memories.
Yeah. So, speaking of that, like connection between sleep and memory, do you want to like maybe elaborate on what your lab does specifically, or maybe
Sure.
some of your like favorite research projects that you've done?
Sure.
Yeah.
Yeah, so what we've been well, there's basically right now two main sort of aspects of the lab that we're focusing on now. One is focused on trying to understand how local brain physiology during sleep across different brain states, whether it's REM sleep or different stages of non-REM sleep, how they are impacted or associated with Alzheimer's disease pathophysiology markers, whether it's markers of inflammation in the brain or in the periphery, whether it's the amount of amyloid pathology in your brain, whether it's the amount of tau pathology in your brain, whether it's the amount of synaptic or degeneration or circuit dysfunction or regional atrophy. Do those things impact how the brain expresses sleep at a local level? Can you map how that changes as pathophysiology changes over time and accumulates? How do those predict cognition, particularly memory
Yeah.
functioning? Does that predict your cognitive trajectories over time? Do people who have the most disruptions of certain aspects of sleep, are they also the ones that you're going to see declining fastest?
Hmm.
And which features of that are important?
Yeah.
Is it certain brain waves like slow waves or certain brain waves? There's another brain wave called sleep spindles. Both
Yeah.
have been associated with memory and non-REM sleep. Those show particular associations with different features of Alzheimer's disease pathology. Does deficits in those or how they interact with each other predict how, burden or accumulation? Is that associated with memory functions? Can you intervene there, enhance those oscillations? Does that have an impact on how they clear the pathology or how they accumulate it? How that relates to cognitive functioning and resilience in the face of that pathology? Though that's one aspect that we're
Yeah.
exploring right now. We use a combination of what's called polysomnography, or basically a sleep study,
Yeah.
with high density EEG. So they try to get a whole head coverage to kind of sense, is it waves expressed in the front of the brain, in the back of the brain, in your temporal lobes that matters. Um, and we combine that with, we get a lot of cognitive measures, we get a lot of physiological measures. We try to get fluid biomarker measures either through blood or saliva, and then imaging, whether it's PET imaging or MRI
Yeah.
imaging, structurally and functionally. We try to kind of get that all together on the same people to try to understand these relationships over time.
Hmm.
Um, the other aspect of the lab is we're really interested in how certain sleep disorders and the features of the disorders are related to Alzheimer's pathophysiology and progression and risk and cognitive functioning. One of the ones that has, I think, the most evidence for being a risk factor for Alzheimer's disease is this sleep disorder called obstructive sleep apnea.
Oh yeah.
Um, so this disorder, it sounds like you already know, is associated with a couple of pretty rough features. One is just constant fragmentation of their sleep,
Yeah.
and the other is frequent intermittent dips in blood oxygen called hypoxemia,
Yeah.
which then can essentially result in dips in blood oxygen in tissues in your body and in your brain called hypoxia. And it's this hypoxic injury or insult that has been associated with degeneration in the brain, white matter dysfunction, pathology of Alzheimer's disease, and cognitive impairments. And we're trying to explore which aspects or features of obstructive sleep apnea and which pathophysiological features link sleep apnea to Alzheimer's disease. And
Yeah.
it doesn't matter when they happen. One of the things that's been emerging from our work and some of the work of our colleagues is that the events are more likely to occur in REM sleep than non-REM sleep, typically. Um, And when they happen in REM sleep, they tend to be more severe. You tend to dip more and spend more time during those events. But kind of the culture of the field and of sleep medicine has tended to be, well, those events in REM probably don't matter as much as the events in non-REM, or it just doesn't matter what stage they're in. It's just the total number that matters. But we're finding a really strong association with cognitive deficits and degeneration in the brain with events that are happening in REM sleep
I see.
specifically. So, like if you have really severe hypoxia or hypoxemia, dips in blood, oxygen,
Yeah.
blood oxygen, you're more likely to have white matter degeneration in your frontal lobes and in your
Uh,
parietal lobes. You're more likely to have degeneration of the medial temporal lobe memory system. You're more likely to have memory impairment, and they're linked to each other. The degeneration of white matter tracts impacts the generation of your memory system and has an impact on your memory. And so this is something we're trying to explore further.
mhm.
And we think there's a lot of reasons why this is particularly relevant for the normal everyday person. One, um, there's a sex difference in Alzheimer's disease risk.
Okay.
And while men are more likely to get obstructive sleep apnea when they get older, women are more likely to have their events being dominated by events in REM sleep. So they're more likely to be REM dominant in their OSA
Oh,
expression.
interesting. Okay.
And because REM sleep makes up 20-25% of your sleep or less, if you take the overall average of events, it looks like you can have a small number. So there may be a lot of women who are underdiagnosed. And this is
Yeah.
also a problem because the typical risk factors for sleep apnea are more predictive in men of having sleep apnea than they are of women having sleep apnea. A lot of women who don't have those typical features of kind of like upper body obesity
Yeah.
or big thick necks, a lot of them still may have apnea for
Also,
different reasons.
I think pregnancy is also like connected
Yeah,
with underdiagnosis. Yeah.
that is true too. Very
Yeah.
good.
So
Yes,
actually, I want to add something here because it's really funny that
sure.
you're talking about this. Or I mean, not funny, but it's
No,
interesting that
yeah.
you talk about this because recently I was interviewing a professor, Dr. Sigrid VC. I'm not sure if you know her.
Oh, yes. Oh,
Yeah,
she's
that's
really
good.
good. I love her.
I feel like I could just tell you every single person I've interviewed and you'd somehow know
It's
them.
a small field.
Yeah, that's what I hear a lot. So, but so I actually I mentioned this in the email. I'm not sure if you remember, but I create like educational posters for
Yeah.
patients at clinics. And one of the posters I've recently been distributing a lot is a poster on obstructive sleep apnea awareness.
Mm.
It's a stop bang survey,
Oh,
basically.
yeah, the
Which,
stopping. Yeah.
yeah, exactly. So Dr. VC basically I was offering the posters for her clinic and she told me how they already like have posters, which is great. But then she
Mm.
told me to consider reaching out to local OBGYN clinics because I
Cool.
didn't realize this at the time, but she told me how OSA is really underdiagnosed in pregnancy and how it can
Yeah.
lead to like or contribute to complications with the
Mhm.
pregnancy and like fetal complications. So I
That's
actually
true.
ended up last week I was actually going to I think on Friday I didn't have school that day, so I went to a local community health clinic and I spoke with their front desk about like the posters and well I'm actually working with them to tailor like a specific poster for their clinic which gets a lot of like which has like OBGYN like services there. So I'm hoping to kind of contribute to that like diagnosis in places where it's often
That's
underdone.
amazing. That's
And
really good works you're doing. That's really
yeah,
important.
thank you. But it's just
Yeah. The,
interesting
the
to hear you
stop
like
bang itself is an example of what I was talking about.
yeah, yeah,
It's more predictive of OSA in men than it is in OSA in women. And actually
yeah,
one of the factors on the stop bang. Now, don't get me wrong, I like the stop bang. It's a really useful tool.
yeah.
Um, and in fact, in my research, I use it
Oh wow.
myself.
Yeah.
But one of the criteria is, are you a man or a woman? If you're a
That is
man, of
that is
course,
true. Yeah.
higher risk.
That is actually true.
And it makes sense because men are more likely to have OSA, especially with
Right.
upper body obesity and that sort of thing. But but yeah, but anyway, but that's great that you're doing that work. It's good
Yeah.
to get out awareness. Certainly that's a problem in pregnancy for sure.
Yeah.
Um and it's probably underdiagnosed in menopause and other stages of life for women too.
Mhm.
And that's a time when it matters for AD risk early on when people are starting to build up the pathology and before it's detectable. So these are really important issues. And one of the reasons why I'm thinking about this is it's possible that people are being underdiagnosed if their overall numbers are high, but they're or low, but their numbers in REM sleep are high.
I see. Yeah.
And women are more likely to have that, and that might be contributing to sex differences in Alzheimer's risk, above and beyond the age effect and other
Yeah.
sort of sex-related effects that are there. Um, so I mean, so there, I think there's a lot of reasons why we're, caring about that. But one of the things that I'm curious about is if we just reduced hypoxemia and REM sleep, does that impact risk in patients with OSA? And one of the reasons why that also matters above and beyond sort of the potential sex effect there is you have, what's considered, you have bad compliance with PAP. It's just straight off the board. I know you talk to anybody, there's a mask you can wear,
Yeah.
there's other kind of ways to approach it, and just people don't like using them for a
Yeah.
lot of reasons. But it's gone to the point where essentially good compliance is, did you wear it for at least 4 hours a night, for at least 4 days of the week? Okay, good. Then you have good compliance.
Yeah.
But, that may be because some people take it off halfway through the night. There's some people who do that. There are some people who just wear it for a few days and it averages to that. And they wear it for the full night. But if you're not wearing it through the second half of the night, that's when most of your REM sleep is. So you might even be treated for apnea. And if you're not treating it during the time when you're having the most severe hypoxemia, you might not be mitigating the risk in the
Yeah.
same way. And so that's why it's important to wear it through the night and to wear it as many nights as possible so that you
Yeah.
kind of minimize the brain damage that you can get from it.
Yeah.
So
And then, so this is kind of like unrelated to this topic, but it's still connected with sleep and Alzheimer's. So one
sure.
of the things that I'm actually currently working on is so I wrote a bill like a few months ago,
Hmm.
or I drafted a bill to push back like high school start times in Missouri to
Great.
8:30 a.m. And I
Yeah.
reached out to a senator about it, and she agreed to sponsor it. So I'm actually
Oh,
going to
wow.
their Capitol this week.
Congratulations.
Oh, thank you.
That's
Yeah,
really
it's
neat.
not filed yet, but she did agree to sponsor it. So
Yeah, yeah.
it's definitely going to be making its way up, hopefully. But
Yeah, we did that in California. There was a
yeah, I
huge
know. Yeah.
statewide push, and,
Yeah.
and I've never seen that anywhere else in the country where it was a statewide,
Yeah, well
you know,
that's what I'm trying to
act.
do
Yeah,
here.
and
And
it's really hard to do the statewide. A lot of
yeah,
them were
that's
trying
true.
to push locally at different districts, and some are interested and
Yeah.
some are not. That got a lot of pushback to get that through.
Oh yeah, for sure.
But it finally got through and it got signed.
Yeah.
And I mean, we're going to see in the next few years the benefits of that. But we know from
Exactly. Yeah.
local changes in school start times, that's had pretty positive benefits pretty much everywhere in the country
Yeah.
when it's happened.
Yeah. And I've interviewed a lot of people who are like advocating for that. And
Hmm.
there's like this
I have myself
organization.
advocated for that in Northern California before the act was passed. There was
Oh wow,
a
that's
local
good.
district,
And thank you
a
for
city of
helping high
Albany, and I
schoolers like
really
me.
pushed for that there.
I actually means a
So
lot. But
yeah.
yeah, no, and also like Start School Later, I'm sure you've heard of it, like the organization.
Hmm.
I've interviewed a lot of people in there, but my point with it is, I'm curious if like you think there's a relationship between like early high school start times and Alzheimer's risk like way down the road, like whether that like sleep deprivation in teenagers could be linked to some sort of potential, um, like pathological.
I don't know. That's a good question. I think, it would, what matters more is the chronic accumulation of sleep loss. And you certainly get chronic accumulation during the high school years.
Yeah.
If you bounce back from that and sleep longer after that, that may mitigate that to some degree. I mean, you typically don't worry about the initial buildup of the pathology until sort of midlife is
Okay.
where you see it really accumulating, but that may be for a
Yeah.
number of different reasons. I mean, there
Mhm.
are certainly some people that you see the buildup of that pathology earlier.
Yeah.
Um, you know, Individuals with Down syndrome have
Yeah.
three copies of the
Right.
APP gene that produces amyloid, and they have a rapid accumulation of amyloid their entire life.
Exactly.
And you know, they very frequently become amyloid positive in their 40s, which is, a couple decades before when you typically see it in so neurotypical populations.
Yeah.
And there has been exploration of the change of these proteins in younger ages and how that may relate to things. Um, it's a really understudied aspect of this, and it's unknown really if that could have a dementia effect. It certainly has cognitive effects. It certainly has mental health effects.
Right.
It certainly impacts suicide rates and car crashes and
Yeah.
spread of infectious diseases and poor cognitive performance, worse grades. Like all those
Mhm.
things are impacted by early school start times and the mismatch between that and their healthy biological sleep schedules.
Yeah.
And, especially if the individuals have short sleep because of it. Like, so are they getting 4 hours a night or something, or 5 hours a night? Um, but I don't know. I don't think there's any strong evidence to
Okay.
suggest that
Yeah.
sleep deprivation there could have an Alzheimer's effect later, but only because it hasn't really been studied.
Right.
There,
And I guess that is a
another
huge
area of
like time
work.
difference too. So
Yeah,
yeah.
yeah, because decades. But
Right.
like you could say maybe there's a permanent effect. I mean, the way that you think about these proteins. Let me put it to you this way. Maybe I'll try to answer this from a different perspective. So when people think about the pathology of Alzheimer's disease, they think about sort of amyloid
Yeah.
proteins and they think
Tau.
about tau
Yeah.
proteins. We all have them, right? You have them,
Yeah.
I
That's
have them.
true.
They're
Yeah.
cycling in a 24-hour rhythm in our cerebrospinal fluid right
Hmm.
now,
Yeah.
right? Um, what matters is not their expression and their existence, matters is their accumulation.
Yeah.
And like once you accumulate enough, you start depositing it in your brain, you lose that circadian rhythm actually. And it just sort of accumulates.
Oh.
But um, if you can kind of shift towards this balance of increasing and decreasing across your day and your night, because it actually decreases in sleep and increases in wake. People at WashU have proven that.
Oh
Have you?
wow.
I assume you've talked with David Holtzman or Brendan Lucy or
I reached
Eric
out
Mosaic
to
there.
I think I'm setting up an interview with Dr. Lucy in February. Like I
Cool.
he
Yeah,
they agreed to do an interview and I
that's great.
yeah.
Yeah. So they know they've done all this work in
Yeah.
humans and in rodents and a variety of different model systems.
Yeah.
And they can talk to you a great degree about how these proteins are shifting and how sleep deprivation impacts that.
Okay. Yeah.
Um, and what matters really ultimately in the Alzheimer's risk space is, are you accumulating those proteins?
Yeah.
Or do you have kind of a net balance where your increase and decrease of them across the day and that, from day to day is kind of essentially net zero, right?
Hmm.
So that is kind of where the Alzheimer's risk comes into play. What sort of sleep deprivation happens in sort of high school, how that could impact that, I don't know. I wouldn't expect it, but then again, I wouldn't have expected that youngest case of Alzheimer's disease to happen. I don't know if you've read about it in China.
Oh.
There was a 17-year-old who developed Alzheimer's disease, and no
Oh
one
wow.
knows
I didn't.
why. There's
Wow.
no genetic risk factor that has been known that sort of drives it. Usually, when it's that young,
Yeah.
it's because there's some dominant gene that's causing that to happen.
Right.
Gene mutation. Ted didn't find any in him, um, and he just deteriorated really quickly, and
Yeah.
that surprised everyone in the field. We still
Yeah.
don't know what's going on with that particular patient, the poor,
Hmm.
poor individual.
Yeah.
Um, but typically you don't see that, right? You typically, it's like, most of Alzheimer's is sporadic, late onset Alzheimer's disease that occurs in older age, though there are a number that are driven by genetic mutations or family history. There are a number that are early even without that. I think 10% of cases are early onset,
Yeah.
and only a fraction of them are the genetic ones that we know about, where we know the genetic cause.
Yeah.
But you know, there has been another aspect of life that people have explored that is kind of similar to what you're talking about. Because what we're talking about is social jet lag and the effects of
Yeah.
social
That's
jet
true.
lag on
Yeah.
health
Yeah.
risk, in particular cognitive decline in later
Hmm.
life. And people are actively studying shift work and how that
Yeah.
impacts risk. And we
Yeah.
definitely know that shift work does seem to impact the AD proteins and does seem to impact risk for dementia.
Yeah.
Now, the question is whether it's, do they do shift work for 20 or 30 years and then go into old age, or do they do it for 5 or 10 years and then they have a normal schedule? Do they still have risk? Do they have less risk? Those
Yeah.
kinds of things we don't know the answers to yet. It's too
And
soon.
I actually have a specific question on that. Like, I'm
Hmm.
not sure like how much you'll be able to answer it, but I'm just curious. So let's say like someone does shift work for a really long time, like you said, maybe like 20, 30 years. Like, does your body not get like used to it to some extent and maybe like the body adapts or I don't know, just I guess how would you like explain that to me?
That's a very intuitive and common question that gets asked
Right.
about that is,
Yeah.
and as a matter of fact, it's based on your people's own individual experience, right? So if you go through a period where you restrict your sleep for a period of time, you start to kind of feel like you're getting used to it. There was a classic famous pair of studies that were published in the early 2000s, 2003,
Hmm.
by two different groups who were collaborating. this group ran by Greg Belenke, who worked at Walter Reed Academy, and this group run by David Dinges and Hans Dongen at Penn at the time.
Okay.
And they essentially took a number of different people and put them into different groups. It's like, okay, you're going to sleep 9 hours a night. And so Greg Blinky took all the odd hours, and David Dinch's his group took all the even hours. So
Okay.
it's like, okay, do people slept, and they kept them in the lab for 2 weeks and said, okay, we're going to have you sleep 9 hours a night, 8 hours a night, 7 hours a night, 6 hours a night, 4 hours a night, 3 hours a night
Yeah.
for 2 weeks, and just see what that does to cognitive performance, see what that does to subjective ratings of sleepiness, and then compare it to people who were kept up for 3 nights without any sleep at all, right?
Hmm.
And, one of the, at the time, a lot of people were using subjective sleepiness ratings because they're really good at tracking how sleepy people were. You just ask them how sleepy you are, and you kept them up. They're pretty sleepy. And in fact, if you look at total sleep deprivation for 72 hours, and while they go through that 72-hour period, you see a pretty steady increase in sleepiness, on top of a circadian pattern. It's kind of like an oscillating pattern,
Yeah.
if you measure it frequently enough. But if you just measure it once a day, you'll see their subjective sleepiness just increases. And then you look at their cognitive performance on a task that's sensitive to alertness and attention, in this case, a psychomotor vigilance task developed by David Dinges. You'll see their performance gets worse and worse and worse. They have more and more lapses. Though, it's not that they can't perform the task. It's a really boring task. All you have to do is push a button when you see something pop on the screen. But it's just, you have intermittent periods of, you have micro sleep and you fall asleep, so you don't respond
Yeah.
for a while. And
Yeah.
so you just kind of sleeping and lapse, and that's called a lapse. So those number of those increase over time, and that tracks with how sleepy you are. And if you do sort of these acute sleep deprivation paradigms, they're very related to each other and they're very sensitive to track each other. But when you start looking at behavior of sort of not total sleep deprivation over a couple of days, but you look over a 2 week period
Yeah.
um, at their performance on an objective task versus how they rate their sleepiness subjectively, you see something very different. So if you look at their objective performance over those 2 weeks period, you get a steady increase in their performance, gets worse and worse and worse, right? Um, as a matter of fact, I think it's, if you go 2 weeks sleeping 6 hours a night, which is pretty common, right?
Right. Yeah. It's actually, yeah.
At the end of 2 weeks, you're performing the same as an individual who's been kept up all night and had no sleep for a day, 24 hours of sleep deprivation on this
Wow.
attention task.
Wow.
If you do 4 hours a night, which is less common but not unknown
Right.
or unheard of, it's like 2 nights without sleep on
Wow.
this performance task. But if you look at their subjective ratings, they go up on like the first day or so, and then they flatten out.
Hmm.
And they say they're doing fine. They
Yeah.
got used to it. They compensated. But their behavior is just worse and
Yeah.
worse and worse. So you can feel like you get used to sleep loss,
Yeah.
but you don't. And we know this from scientific studies where we measure cognitive performance. We know this in scientific studies where we measure things like insulin resistance, glucose tolerance. We have people who are, for 6 months, their typical schedule is 6.5 hours or less. They're profoundly insulin resistant. I know this. That was my first project working as
Wow.
undergrad research assistant at University of Chicago. We found that they were profoundly insulin resistant when they were sleeping in 6.5 hours or less
Yeah.
on a regular basis. So, like, they didn't get used to it. Their pancreas didn't get used to it.
Yeah.
The brain isn't getting used to it.
Yeah.
You might think you're getting used to it because how do you rate your sleepiness? You relate how you feel
It's
related to how you
subjective.
feel at other times. And if
Yeah.
that just becomes your standard
Yeah.
normal, your normal shifts, then
Yeah.
I'm as sleepy as I ever am. So I'm fine.
Yeah.
And in this fact, if you slept and rested, probably feel better.
Yeah.
Especially if you did it for a few days and really let yourself recover and bounce back to baseline. There's sometimes this kind of groggy effect you get when you sleep longer than usual, that can last for a little bit, but then you know,
Yeah. I guess this
recalibrate.
idea of like sleep deprivation, like people subjectively rating it themselves, they think they're doing fine, but in fact they could be like very sleep deprived. It's come up in I think almost every single interview for the past like 10
Yeah.
interviews I've done here. And it's always interesting for me to think about because I think about its implications in like society, especially in like healthcare. where you
Yeah.
might be like a resident or so, like an overworked
Yep.
resident maybe, and like making healthcare decisions, and you might think you're doing fine, but I was talking with Dr. VC about this actually, I think
Hmm.
so, and she was my most recent interview, so it's funny
Yeah.
that we're talking about it again, but
That's
um,
cool.
no,
It's a
yeah,
fascinating political story, actually. If there's
yeah,
anybody that you could talk to about this, I don't know if he's still around taking interviews and doing stuff, but at Harvard, there's a guy named Chuck Seisler, one of the most famous
I've
sleep
heard his
surgeons.
name before. Someone, I
Yeah.
think I might have reached
So
out to him.
he was actively involved in the public policy push for the residency work hour limitations.
Oh wow,
Um, and it took a lot, and they ended up how they are, and there's still an ongoing debate about it.
yeah,
And I think he believes, from what I've heard him talk about before, I mean, I guess I shouldn't read his mind for him and say what he believes, but I've heard
right,
him talk about the idea that he thinks that those regulations didn't go far enough.
yeah,
And there are certainly others that don't really believe in the sleep deprivation issue in medicine, think that it's gone too far, and so there's these forces pushing against each other. But
yeah.
um, the justification for not taking it sleep into account for residents has been there a concern of handoff errors. This idea that if you don't stay on for 80-hour or 120-hour a week kind of, work hours, that you're going to have a lot more handoffs to other people and there'll be errors in the transition. And it sounds
Oh,
natural that you would
I
have
see.
that because,
Okay.
like, there's always, whenever you're turning something over to someone else, there's always a chance for miscommunication that can always lead to errors.
Hmm.
The science I've seen on that suggests there's actually no impact on transition errors,
Yeah.
if you do that. Um, but there is an impact in sleep loss on. But if you look at it, sort of the overall health care outcomes, there's no obvious impact at all for either of those. And so that sort of pushed people to rethink these work hours. But it's probably the way it's studied and what the outcome measures really are. What's really clear from that literature is that mental health outcomes are much better for residents
Oh
if
yeah.
you have work
100%.
hour regulations.
Yeah.
And job satisfaction is better.
Right.
Um, and really the evidence that there's impairments in functioning come from sort of studies where you engage in specific activities. Like one was an example, you do like a very, straightforward standard vascular surgery, and you'd have
Okay.
these sort of tubes, you practice on these tubes, and then you'd kind of test it, have water flow through it. And usually you would do the surgery, an attending or a teacher would look at it and say it looks fine or not, and
Mhm.
then they would test it. And in this study that I'm recalling, there was, sleep deprivation didn't seem to have any effect on what the person doing the surgery thought about the surgery. So they did it fine. The person overseeing it looked at it and said it looks fine. But when they stress test it with water, there was more leaks,
Wow.
which suggests that sometimes the consequences of sleep loss can result in objective outcomes that are missed.
Right. Yeah.
That can have serious health consequences.
Yeah.
Now, that was one study. It was a little study. Who knows if you did it bigger in different ways
Mhm.
that could change things. But, there's a good amount of evidence that the residency hour, you know, hours for residents is challenging,
Right.
especially in travel to and from work.
Yeah.
You know, that was less of an issue when residents were residents because they were residents in the hospital and they lived there. But now that they go home and come back, you have people driving at the worst possible time to be driving.
Oh yeah, that's true. And yeah, actually,
Mhm.
you might find this interesting. When I was trying to get the senator to sponsor my bill, I remember I met with her over a Zoom call to like kind of discuss my
Mhm.
work. And I think one of the first things that I brought up is how like sleep deprivation, especially in teenagers, like compared to adults, it worsens like motor accidents. It's linked to so many like fatal
Yeah.
outcomes, and it's worse for teenagers compared to like an adult too, because teenagers are already like their lateral prefrontal
No.
cortex. I'm saying they, but I mean
Yeah.
referring to me too, I guess. But
You're
um.
talking about the lack of fully myelinated prefrontal cortex?
Yeah,
Is that what you're talking
lateral.
about?
Yeah, yeah, yeah. Yeah. I'm saying lateral because I remember reading about it in textbook, and
Do
I
you
always
mean
like to
lateral
throw.
like dorsolateral?
I'm not sure which lateral. I just remember reading
Yeah.
once like the lateral prefrontal
Yeah.
cortex for like I
Usually when
think
people talk about lateral, they're talking about dorsolateral prefrontal cortex. I mean, there's
okay.
lateral temporal cortices, I suppose, but usually that's
Yeah,
just
I think I am
temporal
referring to
lobes.
the dorsolateral one.
Yeah, yeah.
Yeah.
So dorsolateral, that's really critical for
Yeah.
top-down regulation of
Yeah,
behavior,
yeah, top down. Yeah,
including
that's true.
working memory,
Hmm.
some sort of response inhibition type stuff, though some of that's more ventrolateral. But either way, I guess it's lateral, right?
Yeah.
Ventral or dorsal.
Right. Yeah.
Um, so yeah, that's critical for
Yeah. And
self-regulation.
I was just talking about how like, well, that's already like not fully developed. And then you're
Mhm.
compiling like sleep deprivation on top of it. I think
Yeah,
that's
that's
just a
rough.
recipe for disaster. And I think that was one of the pieces of evidence that like really pushed her to support the bill. But yeah, no, I
Yeah.
mean, I think sleep deprivation connected with like the roads is always like
Hmm.
something to consider. Because you have to
Oh, for
understand
sure.
like the people that like you might get into a crash with, those people didn't do anything like wrong inherently, right? Like because
Hmm.
when you're sleep deprived and making the decision to go onto the road, like
Yep,
you're endangering the lives of other people, which is
that's right.
also like an ethical
Yeah.
um dilemma there, or not dilemma, but like just
It's kind of like,
yeah,
if they decide about if one or two drinks or being buzzed while driving is
yeah,
enough,
that's
or,
yeah,
and in some cases, not to get into political debate, but like deciding to vaccinate or not can impact the health of others, right?
yeah,
And
yeah,
so, like that decision, as fraught as it is for some people, has an impact on the health of others, and that makes it um, a public health issue.
yeah. Yeah. And so coming back to like that conversation earlier we had about sleep deprivation and Alzheimer's, one of the questions I forgot to ask
Mhm.
and I wanted to ask about is like wearable technology and how
Sure.
like I think I've personally like seen it rise, especially like within my own family and people around me. And I'm curious like what you think maybe like wearable technology, especially with like Fitbit or Aura and all the
Mhm.
data that it can store. Perhaps like do you think in the future that can be used for even more like in-depth research analysis of like outcomes like disease wise linked to like much longer like longitudinal studies given that
Mm.
there's so much technology now like wearables
Yeah.
wise.
Yeah, I mean, there's a movement in research space and of course in sort of like consumer space, right?
Hmm.
For this push for kind of measuring different aspects of physiological health. And I
Yeah.
think the advantages of it, I wouldn't say in more depth, but I would certainly say you would get more
Quantity.
information, like you said, about longer
Yeah.
trajectories over time, because people
Yeah.
will wear wearables for a long time, right? You're not going to do a polysomnography. You're not bring someone into the lab every night for 2 years, right? You can barely get
Yeah.
them in once
Yeah.
or twice.
Yeah.
So, but there are a number of sort of wearable technologies in the research space that are sort of better for kind of estimating sleep behaviors. I think once some of those technologies like Fitbit get better, I think Aura is better than Fitbit. And there's a lot of people doing
Right.
research with Auras.
Yeah.
People are starting to do research with Fitbits, but they're not as good as some of the other wrist actigraphy monitors that are recently created in
Do
the
you know
market.
Dr. Michael Grandner by any chance?
Yes,
Yeah, I think he
yes,
did
I
something
do.
with Fitbit. We were talking about it
Hmm.
during our interview, but
I think
yeah.
he didn't he do a study recently. We compared a bunch of different devices with Fitbit. I think he did.
Oh, I don't know about that one. I don't
I've
think we
talked
talked
about
about it,
it,
but he might have. Yeah.
but
Yeah.
But yeah, it's like it's all about scaling, right? So
Yeah.
scaling and longitudinal work. So one of the thing that wearables can do is you can have bigger studies. You can have many more people doing it, and you can get better representation across different groups and risk at risk groups or higher, lower risk groups. You can get sort of more representation
Yeah.
because you can scale, you can do it in their own homes, and you can do it for longer trajectories because people are willing to wear it for a longer period of time.
Yeah.
So I think there's a lot of utility and use of that. But there are certain things you won't be able to measure, right? Like,
Yeah.
so there are wearables that are starting to look at EEG, but
Oh,
they're usually mostly forehead and local EEG measures. Um, but they're giving you some brainwave measures. Um, I think they will all provide a lot of use for the field and looking at risk once we sort of, as we're exploring their relationships and as we nail down specific biomarkers. But you won't have a full understanding of what their brain is doing during
right.
sleep because you're not measuring everywhere. But
Yeah.
you don't have to do that for the bigger studies. As long as you know sleep related markers that are tracking with
Mhm.
Alzheimer's disease, you can follow those in these wearable technologies. I think they serve their purpose in a research field, right? So larger studies with simpler measures can give you very, very valuable insights. And what
Yeah.
they'll really be useful is things like trials and understanding if you can manipulate something about sleep or manipulate something about something else that interacts with sleep, can you have an impact on the 80 outcomes, right?
Yeah.
That is going to be really, really useful in that
Yeah.
space.
And
Um,
okay, yeah.
yeah, but sort of exploring mechanism and trying to explore and identify biomarkers, you probably would still need some of those in lab studies with more comprehensive measures. So they all give their benefits and minuses.
Yeah.
Using these wearables will be very useful, and they're going to improve over time to get better and better in it. That's going to
Yeah.
be really useful.
And connected to this idea of like scale, not necessarily wearables. I remember I was talking
Mhm.
with Dr. Grander about this. I'm not sure if he did the study or he was talking about the study. I don't particularly remember, but he was talking about how we were talking about daylight saving time at one point, and he was talking about how when you scope out and look across like millions of people, you'll see
Mhm.
that like that shift, the day or like the time of the shift is associated with so many like events like cardiac events and
Yeah,
stroke, etc.
stroke.
And he was telling me about how like you don't see that unless you look at millions and millions of people and
Yes.
there's like a very very small change. And that's how you're able to find that. Like you're not able to see that unless, if you have anything less than
Mhm.
millions of people. So I don't know. I just wanted to mention that because of the scale
Oh,
that you're talking
absolutely.
about. Yeah.
And when you get into problems that are so multifactorial as things like strokes and heart attacks or dementia, right?
Yeah.
You need to have that kind of information to identify all the risk factors and all the behaviors that are and all the mechanisms that are impacting these diseases so you know where to target. For sure. Yeah.
Yeah.
And that's why scaling really matters. And certainly treatment scaling will really matter if you have new novel treatments you want to test.
Yeah. So I know we've been talking a lot about like the mechanisms or like potential like connections between like sleep, memory, and like dementia and just like
Sure.
pathological changes in general. But I wanted to like kind of go on the side of like tips or like
Uh,
advice for people to kind of learn to mitigate their risk in a way.
Sure.
So what is like some advice you have for like the general public who like let's say someone like watched some of this interview and they skip
Hmm.
ahead because they want to see something. Okay, like I
Right.
understand maybe sleep can be
Yeah.
connected with Alzheimer's. What's something I can do to like mitigate that risk? So,
Right.
yeah.
Yeah. So that falls into two different sort of categories, I would say. The first and probably the most critical one is that if you have any evidence that you think that your sleep is not restorative or that you feel that you might have disturbed sleep,
Hmm.
it's really important to go talk to a board certified sleep medicine specialist, whether it's a physician boarded in sleep medicine or if it's a psychologist boarded in behavioral sleep medicine, to talk through and see are there any sleep disorders that could be treated and that they can help you with, right? Whether it's
Yeah.
sleep apnea, insomnia,
Yeah.
something else. That's probably the most important thing you can do is to try to target that if you have it, because sleep disorders are treatable, right?
Mhm.
For the most part, they're treatable. You can intervene on them. Now, there are some sleep disorders that are sort of more markers of something worse, and you can kind of mitigate the symptoms, but you're not treating the outcomes.
Right.
An example of that is, the strong connection between REM behavior disorder and what's called synucleinopathies like Parkinson's disease or Lewy bodies dementia,
Oh yeah, yeah.
etc.
I was gonna say, is that connected to the Lewy bodies? But
Yes, it
yeah,
is.
yeah,
And I think it's something like 80 or 90% of people that have REM behavior disorder in, 10 to 15 years develop one of these other
yeah.
disorders. And it's thought to be kind of an early sign. But now, REM behavior disorder is a very specific thing. That's
Right.
not the same thing as sleep talking, sleep walking, or sleep eating, or sleep driving, or all those weird
Yeah,
behaviors people do in their sleep. That's
yeah,
different, right?
yeah,
Those are behaviors happening in a non-REM sleep, and they happen, and especially in kids, and people tend to grow out of them, but not everybody. That's very different from you lose your motor inhibitions and you act out your dreams, right?
yeah,
Um, but things like sleep apnea, things like insomnia,
yeah,
they're very treatable.
yeah,
And so if there's any risk conferred from those disorders, if you intervene to treat them, that's
yeah.
really important.
And
So that's the
yeah,
most important thing I'd say.
yeah. And
Go
I,
ahead,
I was just
sorry.
gonna say real quick before like you continue, like that's
Mhm.
what I'm hoping like the posters that I'm creating are able to
Yeah.
contribute because especially with like so I made like multiple right now. One is on healthy sleep habits, which I hope will
Mhm.
be helpful, but really like the
Yeah.
most meaningful one to me personally is the one on like the Stop Bang survey for obstructive sleep apnea,
Sure.
where like I'm hoping like even if just a few people can see that and maybe like if they have risk factors like meet someone, I think
Yeah.
I'm hoping like those posters can kind of help with that idea of getting them treated because not
Mhm.
everyone is aware that they might have one. And I think,
Right.
like you're saying, it's important to like get that checked. So
Yeah, for sure. And there may be some people who don't want to know they have a sleep disorder. And
Right,
so
right.
one of the ways you convince them is you talk about the side effects of untreated disorders.
Yeah.
Um, so the other side of it is the sleep hygiene tips that you kind of
Okay.
alluded to.
Okay. Yeah.
And it's sort of like if you do and other than sleep hygiene and treating sleep disorders, there isn't really a magic recipe, right?
Right.
You know, it's just, prioritizing your sleep is an important life behavior. It's one of the pillars of your health,
Yeah. I mean, we
alongside
spend a third of our
exercise and
lives
diet.
like asleep.
Yeah.
So, yeah.
Yeah.
So,
And, some people think that's a and the feeling of having, having gone through a full sleep and waking up and feeling rested, it's just a really good experience. Not everybody can experience that, unfortunately.
yeah.
Um, but Um, but so the sleep hygiene tips, they're probably really similar to ones you said, have very regular patterns. Make sure you have an adequate amount of sleep set aside for yourself. For adults, the recommendation is 7 to 9 hours per night.
Yeah.
The that recommendation, if you're younger, differs. I know a lot of adolescents, it's more sort of older developing adolescents, it's more sort of the um, I would say 8 to 10 hours a night. And then as you get younger, it's even more sleep that's recommended. Um, but and there's some discussion about whether a 65 plus, if the
Like
recommendation
six
should
and a
be
half.
6.5 to eight and a
Yeah.
half.
Yeah.
Um, but what all of these recommendations for duration all share in common is their ranges, which recognize that there's
hmm
a distribution in the
Like the
population. Some people
chronotypes,
just
for
need
instance.
more, and some people just need less.
Yeah.
And it's a relatively tight distribution, but there are tails, and you have people who naturally sleep 6 hours a night, and their sleep is very different. Um, Matt Walker is famous for saying that if you look at those people that just need 6 hours a night and you express them as a percentage of the population and round them to their nearest whole number, you'd have exactly zero of them. And that's just to show like how rare they really are.
Yeah.
Um, so duration is important. Making it a regular timing is important. If you shift your timing of when you go to bed, when you wake up every day,
Mhm.
and you vary a lot, that can cause, circadian misalignment and disrupt your sleep.
Yeah.
Make sure that your sleep is a relaxing routine at night. Some
Yeah.
people take, kind of warm baths before they go to bed. Some people read, kind of pleasure relaxing reading, not like you don't want to do your work in bed. You don't want to do your work right up till you
Yeah.
go to
And
bed.
actually,
You don't want
I
to watch
think
angry political pundits at night before you go to bed.
you know what's
You
really
know,
funny? I
yeah,
think I was just on Instagram like a few hours ago,
yeah,
and I followed Dr. Walker, and he
mhm,
literally just made a post about this a few hours ago. He was talking about
yeah,
like Pavlovian conditioning for your bedroom, like don't spend more than 30 minutes awake in your bed. So it's really,
yeah,
really funny that we're talking about him and
yeah,
the
yeah, yeah,
idea.
yeah,
And
yeah.
I just saw something about that. So
There's another colleague actually of
yeah.
mine who she said that one thing that she recommends is like think of something that will make you laugh before you go to bed, or something that kind of, think something funny, because I can put you in a positive mood as you go to sleep. And I like that actually. I think that's really nice because you
Yeah.
want to get yourself out of the stress mindset
Yeah.
that promotes insomnia, really.
Yeah.
Um, a lot of people, especially people with insomnia, they will spend a lot of their nighttime in sleep, awake, ruminating and
Oh yeah,
stressing about
rumination.
things
Yeah.
happening during daytime, or the things that will happen during daytime,
Yeah.
and they're destroying their sleep like that.
Yeah.
And you can't help it, you're ruminating. Where else, what other time are you not doing something, and you have all that time to stay awake and
That's
worry
true.
about things,
Yeah.
right?
Yeah.
So it's kind of convenient, but it also makes your sleep really worse. And some therapists will try to say, well, let's have a worry hour and have you like have dedicated time every day during the day where you say, no, no, this is the time I worry about stuff, and I'll
I
actively
guess like
ruminate
journaling
then.
kind of like connects to that a little bit, maybe.
Yeah,
Yeah.
journaling is another thing for
Yeah.
sure.
Yeah.
Um, Journaling can also be used to increase your memory of your dreams if you're trying to become a lucid
Oh
dreamer, you're
yeah.
trying to
You
remember
know,
all your
I
dreams.
have a friend who was asking me like for tips on lucid dreaming.
Hmm.
I remember telling him how like when I was younger, I used to be obsessed with that idea of like
Hmm.
remember I had this one particular
Same.
lucid dream where I was like being like a superhero in my dream, and I've been trying to like chase that feeling ever since. I remember like
Yeah.
writing down there's one note page on my phone. It's like a very, very vivid like description of a dream. And I remember it was so interesting because at the time it was like a very interesting connection of everything that was in my mind like during the day. But
Mm.
somehow my dream, like my brain came up with a way to like connect everything through like me walking through some stairs. Like it was a very intricate story, and
Hmm.
I was impressed with my brain. Like I was like, wow, that's
Yeah.
actually
Our
very
brains
interesting.
are pretty creative during
Yeah,
sleep. It's
I know.
during REM sleep for sure. The
Yeah,
REM dreams are very interesting.
yeah,
Um, and it can be quite scary.
yeah.
So other tips, make sure that it's cool, quiet, and
Hmm.
dark,
Yeah, yeah,
That's pretty straightforward. Another one that I like to promote was a circadian scientist who said this, and I stole it from him, and I say it ever since.
yeah.
Um, is make sure your night lights are red or at least a
Mm.
warm color,
Or like
not
orange.
a
Yeah, like red
yeah,
orange. Yeah,
orange or red. I know red is a harsh emotional thing for some people, but like
yeah, yeah,
orange, yellowish is probably fine. You want to
yeah.
stay away from white light. You want to stay away from green, blue
Like
light.
green and blue. Yeah, yeah.
Yeah. And white light contains green and blue. That's why it's not good either.
Right. Yeah.
The reason I'm saying that for those who don't know, you have special cells in your eyeballs that actually measure light in the environment and helps entrain your circadian rhythms. It helps line your circadian rhythms up with the external world. And if
Hmm.
you're seeing bright light in the middle of the night, that could trick them and free in and shift your rhythms. And
Yeah,
so it's, those cells are very attuned to green, blue light, and they are blind to red light.
yeah.
So it's better to have night lights if you're going to get up in the middle of the night to go to the bathroom or whatever. I know there's a lot of people who are older one of the most common questions I get when I give talks about sleep and sleep health and talk about sleep hygiene. There's a
Yeah.
lot of anxiety about I have to get up to go to the bathroom every night, like 3 or 4 times a night to pee because I'm older and that happens because of prostate size. Um, so the thing that matters is not that you get up to go to the bathroom. The thing that matters is that how long does it take you to fall back asleep? So if you can get back to sleep just fine, don't worry about it. If you have trouble getting to sleep, it's really dealing with that's the issue, not getting up to go to the bathroom. But
Yeah.
if you want to avoid getting up to go to the bathroom, some people do suggest drinking less water right before bed and trying to hydrate earlier in the evening. And that is a way to do it. But I wouldn't be overly concerned about that.
Yeah.
The most important things is giving yourself adequate amount of time, making sure it's a resting and relaxing kind
Hmm.
of experience, making sure that you have the environment set right, it's quiet, cool, and dark, and keeping it at the same time every day. And if you do that, and if you have any sleep disorder, kind of you still do all those things, and you still don't feel like your sleep is restorative, you still feel like you have a problem.
Yeah.
You might have a sleep disorder. You might need to
Right.
talk to someone, and that would be my recommendation. There's a lot of ways that people might self-medicate their sleep. They might take a bunch of over-the-counter melatonin
Oh, that's
or,
true. Yeah, a lot of people do.
take a bunch of CBD
For
or do
teenagers
a bunch.
specifically, like a lot of us take energy drinks. Like I personally don't, but like
Right.
caffeine and energy drinks are so abused. Um,
Yep. Uppers and downers, man. Uppers
yeah,
at day and downers at night.
yeah. Uh,
It's what they call, what is that? They call, better living through chemistry, I think is the phrase that people use for that.
oh, okay.
Um, but it's your body's evolved to be a certain way for a
Hmm.
reason,
Yeah,
and messing with it and hacking it
yeah.
can have consequences.
That's why I personally don't drink caffeine. Like to be fair,
Mm.
like I've never like felt its effects when I was younger, but I mean, granted, I don't think I was drinking like enough or like drinking it like in a way that would either
Yeah, I mean,
like help me sleep less.
having
But
some now and
I
again is
just
not a
yeah,
problem.
yeah, yeah. For me though, like I've been able to
It's
get
like
by
the
without it. So
250 milligrams of it every day is a problem. That 250
right.
milligrams of caffeine has the same behavioral effects of 5 milligrams of amphetamines.
Oh wow. And I mean, I
So
guess
that's like
caffeine
a
is a
couple
drug,
Starbucks coffees,
but yeah,
something like that.
yeah, it is a lot. But yeah, no. The other thing I was going to ask about, like connected
Yeah,
to this sleep thing, is chronotypes. So
yeah.
I'm curious, like specifically though, I have a specific question for you, like with your work. Um, is it possible that like certain chronotypes are linked to like Alzheimer's because society favors like the early morning owls compared to the evening larks?
That's an
Is that,
interesting
is that
question
right?
because there's actually a couple things embedded in there, right? There's
Okay,
the
yeah, yeah.
the aspect of society imposing a certain style of behavior for certain age groups,
Hmm.
having influence interacting with someone's individual circadian preference.
Yeah,
And then which aspect of that might be a dementia risk factor.
yeah.
I'll start with the simplest form, which is that is if you're an owl or a lark, a risk factor for dementia. The state of the science on that right now is there's no strong evidence that that's the case per
Okay.
se. I've seen evidence both ways. I've seen
Oh wow.
evidence that
Okay.
being more delayed increases your risk for Alzheimer's, and then being more advanced increases your risk for
Okay.
Alzheimer's. The typical thing you see with age biologically is you get a shift towards advance as you get older.
Right.
The thing that's more concerning than your timing shift, your phase preference shift, is really how stable are your rhythms? So do you have a clean circadian rhythm where it's you're active during the day and sleeping and resting at night? Do you have biological measures of your temperature, of your hormonal secretions? Those show a clear amplitude of your rhythm from day and
Hmm.
night, right? When that starts to disappear, that becomes more of an issue, probably because it relates to being misaligned and being more likely to be less consistent in your rhythm, and then you can get sort of internal desynchronization, and that can be problematic. So that is probably more of the factor than being an owl or a lark per se.
Yeah.
Some of the thinking has been it's pretty typical to be advanced as you get older. So if you are delayed, then that must be weird. But that may not mean a dementia risk, really, per
Right.
se. And every individual has their baseline, and they shift theoretically shift along it through their life, right?
Yeah.
But it's a distribution, right? There's some people who are owls and some people who are larks.
Hmm.
There's some people who are, but you're more likely to be sort of neither of those things. Um, Trending towards morning type or a lark when you're younger, and then when you get to adolescent development, there's a strong shift towards delayed,
Yeah.
and then that shifts back slowly towards kind of neither type in your sort of young
Okay.
adulthood, and then
Yeah.
drifts towards pretty strong morning favoring sort of lark type when you become older. And that's sort of
Okay.
the typical pattern. But your starting point matters too, and that's highly genetically determined. So there are very specific circadian genes. If you have a certain type of mutation, you're much more likely to be a delayed type or a morning type. And, you may shift in that axis throughout your life. But, you know, there is a lot of evidence that there are other links between being delayed. So if you're an owl, you're much more likely to have metabolic issues or
Okay.
anxiety and depression issues.
Okay.
There's strong literature on that. And that isn't when you're older, that's like anytime,
Okay.
in,
Yeah.
in adulthood or young adulthood. Um, and maybe those things can contribute to dementia risk later on in your life. I don't know. But certainly
Yeah.
depression, anxiety are risk factors for dementia. And if they go untreated for years, that might be something. That's more the anxiety disorder and depression rather than being an owl per se, right?
Yeah.
Um, but so I don't know if I fully answered your question. I don't think
No, yeah,
there's
that was
strong
interesting to
evidence
hear,
just to
I
be an
guess.
owl or
I
lark.
didn't realize like the nuances within like the lifespan
Yeah.
of like the shifting clocks.
Yeah.
So that actually makes sense though, like the explanation.
Yeah, I
So
mean, actually, the shift in to be more delayed, which is one of the main reasons why you're such a strong advocate for delayed start
yeah,
times, right?
because
For
I
middle school,
myself
high
am like
school,
right now
that
I'm
is
shifting.
biologically driven.
Yeah, that's true.
And it's exacerbated by external things like how many electronic devices you have in your bedroom.
Right.
But it's there even in the absence of it.
Yeah.
It's there in other species other than people.
Yeah.
It's been measured on 6 out of 7 continents because people haven't
Ah,
studied it in Antarctica because there's no schools in Antarctica.
yeah.
At least that's not to my knowledge anyway. But
Yeah.
but this has been seen in industrialized and unindustrialized societies. There's this shift.
Yeah.
Um, and it's probably the most sort of obvious shift to being, a different type of, owl or lark type, at any point in lifespan. But, the two biggest obvious ones are puberty happens and you get this shift.
Hmm.
That's why this shift happens a year earlier in girls than boys on average, because when girls go through puberty earlier.
Hmm.
Um, and you get another shift towards being an owl or being a lark, being a morning type
Yeah.
when you go into older age.
Hmm.
So those are kind of the two biggest known shifts. But
Yeah. Yeah, no, that's interesting that you said. I remember I was interviewing Dr. Karskadin from Brown on like the
oh, cool.
shifting
Yeah.
because I know she
She
did a
will
lot of
know a
work.
lot more about this than me.
Yeah, yeah, yeah. No, but so
She
actually,
trained, she had the same mentor that Chuck Seisler did. So she's another obvious famous, she's
oh
like
wow,
the grandmother of pediatric sleep research.
yeah,
She and Chuck Seisler both trained, or well, let's see, Chuck Seisler trained with Bill Dement, that trained with the great Nathaniel Kleitman. But yeah, and Mary trained under Bill Dement, so she's kind of in that tree. Some of the
Wow,
more
that's
famous sleep
crazy
researchers.
that the mentor must have like has having such a crazy impact like through like the people that they mentored. That's
Yeah,
amazing to see. Yeah.
yeah. No, I mean, when you're in the field, you learn these names, but like some of the people you talk to are some of the most famous people in the field. So
Yeah.
if you could talk to Mary, you might be able to talk to Chuck Seisler.
Yeah. I think
If
I
you
might
haven't
have
met
sent
him.
him an email a long time ago, but I think at that
Yeah.
point my podcast was much smaller. I think I only had a couple interviews. So
Mm,
I do
mm.
you know Dr. Frank Shear?
I've heard of Frank Shear. I
Yeah,
don't
I
know.
interviewed him. He's also at Harvard, so I might like reach out
Nice.
to him again
Yeah, he might have a
later.
connection. Yeah.
But yeah.
I
No.
mean, Chuck Sizer might be retired by now.
Yeah, I did look at his profile. He seems pretty
Yeah.
older, on the older end,
Yeah.
but yeah. No, so I guess my final question for you is
Mhm.
what kind of like research developments or research projects or questions are you most excited to explore over the next couple of years, and where do you see like
Mhm.
the field headed as a whole in terms of like sleep medicine or just sleep research?
Yeah. Yeah. So I guess probably I will stick more to the sleep dementia, sleep aging side of
Okay.
it, just because that's the area I'm in. And
Yeah.
once you get global, boy, there's so many different directions I
Yeah,
could go
that's
with
true.
that
There's a
question.
lot. Yeah.
Um, but I would say one of the biggest things that we need right now in the sleep and dementia space
Mhm.
is the clinical trials proving or testing the hypothesis, really one way or another. Can you reduce dementia risk by treating sleep disturbances or enhancing sleep in some way?
Yeah.
That we have a lot of cross-sectional data. We have some limited longitudinal data. We have some experimental manipulation data. But we don't have the clinical trial data. And I
Okay.
think that is going to be absolutely necessary to test this hypothesis to see, can we reduce dementia risk by enhancing or targeting sleep in some way?
Yeah.
So I think that is going to be a hot topic of interest. I think the most promising avenue to explore in that space is definitely in the sleep apnea side of it. I
Okay.
know there's a ton of interest and excitement in the glymphatic system space,
I
but
did
that is
interview someone on
still,
that recently.
yeah,
Yeah.
Jeff Iliff or Miranda Lim would be great people to talk to for
I think
that.
actually, do you know Dr. Erin Hanlon by any chance? She's at
Yes,
U
I do.
Chicago. I think
Yeah,
we
yeah,
may
yeah.
have talked about that a little bit. I
Okay,
remember when you
perfect.
mentioned U Chicago initially, I was thinking of that interview I
Yeah.
had with her. And
Hmm.
and even in Dr. Walker's book, like he mentions U Chicago within like the first couple pages, just talking about their experiments, like
Yep.
and how instrumental they were.
That's where Nathaniel Kleitman was.
Oh, really? Okay.
Yeah,
So it all kind of ties together,
he's
I
one of the
guess.
most famous
Yeah.
people in the
Wow.
sleep.
Yeah.
Did the original cave experiments.
Yeah,
Really
that's exactly
interesting
what
stuff.
I was
Yeah.
talking about the cave experiment. Yeah.
Yep. Yeah. So, but anyway, I think, there's a lot of excitement in the lymphatic space, but there still needs to be definitive proof that it actually plays a causal role in the Alzheimer's
Yeah.
story in relation to sleep.
Hmm.
And there's a lot of evidence supporting its possibility of being there, but it's not established yet.
Yeah.
But it's pretty established that sleep apnea is a risk factor for dementia,
Right.
and you can treat it and manipulate it. And there's some proof of concept evidence that if you treat it, you actually impact 80 proteins over a couple of years.
Wow.
So actually seeing that might be really useful to see, and that would be exciting to do. And that's one of the things that I'm interested in looking at. The other thing I'm really excited about looking at is to see, can you map the progression of Alzheimer's disease by just looking at different aspects of sleep expression?
Mm.
Can you then measure somebody and know, okay, these are the different things that are happening in your brain right now, and by targeting these sleep features, we can actually affect them on the stage of inflammation, on
Yeah.
amyloid tau, and synaptic integrity. That I'm really interested in seeing how that expression changes over time, and if the relationships change before you're amyloid positive, after you're amyloid positive, after your tau and amyloid positive, after you have neurodegeneration. Does the sleep process migrate and change across the brain as the progression changes? And can you stop it
Yeah.
by intervening locally in how the brain is expressed? So I'm interested in that kind of size of it too.
Yeah.
Um, and really trying to understand the mechanisms of their relationships will be really interesting. But the most important thing for people will be, can you actually reduce risk by treating or targeting sleep? And that is a whole avenue that needs to be explored. But there's going to be a lot of nuance,
Yeah.
and we haven't dug up all that nuance yet mechanistically.
Yeah. But no, I mean, that's exciting to hear. like that
Yeah.
work. And I'm also hoping to keep up with it over the next couple of years. I think as I go to college, I'm also hoping to get on like the research side. So that's also why I asked this
Great.
question in part. Like I'm also just
Yeah.
curious, like what excites me the most to like contribute to
Hmm.
hopefully down the road. So
Yeah. And congratulations on your brain bee
oh, thank you, thank you.
performance.
That was a long
Yeah.
time ago, actually. That
Yeah.
was back in 2023. That's after I won the St. Louis version. That's how I actually
Mhm.
got the internship with Dr. Herzog at
Right.
WashU. Um,
That's
and then
cool.
that's how I kind of got in, like into like the academia of the
Yeah.
neuroscience world from there. But yeah,
But yeah, well, we'd be lucky to keep you. So, do you know where
yeah.
you're going to go? Are you what year are you? Are you
I'm a
senior
senior
now?
in high school.
Yeah, yeah.
Yeah.
So, do you know what colleges you're looking at? Have you
Um,
applied to them already, I assume by
yeah,
now?
yeah. I'm basically waiting for the decisions. So
Gotcha. Well,
yeah.
my fingers are crossed for you and hope you get your
Thank you.
first
Yeah.
choice.
Yeah. But on that note, thank you so much for joining me today. I think we had this is our longest my longest conversation on the channel, so it was definitely very
I tend
fun.
to ramble.
Yeah, no, I mean it was fun talking to you. I definitely like
Yeah.
opened my mind to a lot of perspectives I never considered before. But yeah, thank you.
Well, it was a pleasure, Sanjay, and good luck and everything. Love to hear how you're doing going forward.
Thank you.